Let us start by discussing the current situation in terms of log collection. As I mentioned in the introductory video of this series, this is mostly related around Linux system because this is where containers and Kubernetes and all that stuff resides. This stuff is also applicable to the Windows world, but we're going to be centric around Linux here. So in a system where you may have a host and multiple containers, what you have is that every one of those communicate with a shared kernel. Again, the introductory video talks more about this, but the kernel is shared. But the host talks to the actual kernel by making system calls. For example, one would be to launch a bash shell to an exec. This other container may be sending a file read operation, and it may be getting a response back actually the other way around, right? It will be the write will be going down and the read will be going up, but you get the point. And this other container might be doing say a file open operation, and all these are just system calls. And what a process in Unix that has been almost forever there from the beginning called admin, and most people refer to it as admin-d for the daemon. Admin-d does is that it transforms each system call into an individual log, and that's what we have been using for monitoring security in Linux system for years, right? But we will see some of the limitation of this mechanism of doing that, and the main one is that to the kernel, every system call is just a system call. I don't know whether it's coming from a host, a container, this and that. I mean, are you going to spit out a log out of every system call I get? So no security conversation is complete unless we talk about net flows, because there are many things that the system logs does not tell you, particularly things happening on the network, and that's what net flows has been so useful forever. And what are the type of things that you get from, for example, from the headers of a TCP/IP header? So you get source and destination IP, port, you get the type of protocol being used, you get things like very important, like amount of data received or transmitted, which is important when you are determining whether some exfiltration data has been successful or not, and how much of it has actually been going out, etc. So very, very useful type of information, and this is what is called standard net flows, and they have been forever. I mean, Cisco created this standard and has evolved. I believe it is in version 9 right now, and everybody uses, so there's nothing questionable about them. Now, also later on from the actual payload, because there are things like, for example, in the DNS request and response, there might be some, data being sent and like that. Many other things in networking. The headers does not give you visibility into the payload, but that's why an extension to the standard net flows allows you to get things like a hash of every file going through. For example, if it's a DNS, you get all the fields for the DNS request as well as response. So you can do determination of attacks being hidden within DNS traffic, and I have done videos on that. And this is what is called IPFix flows, right? It's also a standard. It's actually very well understood, and it extends the basic standard net flows into additional things that you want to provide information about, right? And this is just the DNS is just an example. There's plenty of. What is so remarkable about the net flows is that they are very concise. I mean, instead of holding storing all the packets, and that will take a big amount of data and this and that. No, the net flows extracts metadata about the headers and the payload and send you that in a very concise way. So with those two things, we've been doing security for quite some time. However, there are obviously some issues that we are facing, particularly now with the prevalence of the cloud. Issue number one. Well, obviously, from one side we have system logs, and on the other side we have networking information or net flows, right? And they are separated. And that's not good, because unless you have something like QReader that on a single offense can combine logs and flows, then you need to go to screen 1 and screen 2 and make sense out of the two things together, right? So that separation is not a good thing. Let's talk about the other one. auditd, which is this process of logging in Windows, in Linux rather, sorry, is it's really heavy. It's not a light process in terms of performance. There's a lot of redundancy on the data being sent, and so that doesn't make it as efficient as it could possibly be. And the part of the redundancy has to do with the fact that every system call, the kernel has no awareness of, this is coming from this for that, so everything gets actually sent and resent, and there's that duplication. Let's talk about the third issue. Well, in these logs, there's no container information. There's no container awareness. Why is that? Well, again, because every system call comes from a process, and what admin does is, well, this process did that process did this. Well, from which container it came, I don't know. I don't know. This auditd was created before the age of container. And again, I'm talking about things as is happening in admin today. So maybe by the time you watch this video, maybe you watch it a year from now, you will see that maybe, and I have no way of knowing that, admin includes that part or not, right? But right now that's the case. Issue number 4. The logs created by admin what I like to call human formatted. I mean, these are textual, these are talkative logs that tell you this is happened, file has been opened, file has been closed, and this and that. And the problem with those logs that are in human formatted language is that they are very hard to be read by machines, and that's why we need to use regex, and I don't think anybody loves doing that. So that's an issue. Point number 5. In admin there's no ancestry. Sometimes you hear the word provenance, which means who is the father of which, who is what process started this, and then this other sprung another process, and so on and so forth. So I don't have a way of really knowing from a log where did it come from. Issue number 6. At least on admin there's no file modification information. So you get file open, file close, delete, etc. But when a file gets modified, you don't get a log for that. And that's kind of crucial if you want to detect things like ransomware, where the files are massively being modified because they are being encrypted. Issue number 7. There's no API. And today, this is like a capital sin. You need to have API in these days to work with all these. And so these and the fact that there's no container information then makes it perhaps not the best things to work on the way. And also, more importantly, this situation has forced, or you can say has given the opportunity to companies to get into what I loosely call the stitching business, meaning you need to put an agent on the kernel of every one of these systems to intercept and not to intercept, but to read the system call, and for example from the GUID see whether this process came from that process and this, and so you need to keep the agent with a lot of memory to start mapping things up. You need to look at the timestamps to see what is going on. You need to look at multiple things And this is things like that agents like carbon black, FireEye, and others do in order to give you, this process comes here and then it spawns another process and goes here and this spawns another, and to put all this together and produce those nice graphics that makes people buy this technology. And you need that because the logs alone does not give you all that information. Let's enter and talk about SysFlow, because obviously I'm mentioning all these limitations because these are limitations that SysFlow eliminates. Number one, and excuse my crude drawing, it puts a passive tab, and it's very light actually, on the system to provide networking information. If a process is launched and opens a file and then makes a connection to a remote host or whatever it is, all that information, and you'll see that later, is actually sent as part of SysFlow. Very, very special. So it's very light, and the information is very concise, more on a graphic that I'll show you in a minute. From the actual creators of this technology. Of course, it's definitely container aware, and that's one of the key things because it's modern. The logs are formatted in JSON, so no need to do regex and any of that stuff. Definitely, there's complete ancestry. So if you get a particular process from the object ID, more on that later, you'll see where these actually, which are the parent, great parent, great grandparents. I mean, I can go all the way to the first process that started all these, and all that information is provided. Of course, it provides file modification logs and has a beautiful API. So these are the issues. These are the to me, very important reasons why SysFlow was created. This is a work from several IBM researchers, and I'm going to be, as I mentioned in the introductory video, I will provide a paper that they wrote and additional pieces of it as I'm getting them from there. And the other great thing about this is that this is open source. Okay. Just in case you haven't watched the introductory video of this series, this is the paper I was referring to that was written by the creators, Terry, Federico, and Xiao Kui. Forgive me, each of you, if you watch this video ever and then I did not pronounce your last name right, but I hope I've been selling the fruits of your work in the right way. Let's actually talk about why and the format of the logs in SysFlow and why they address all those issues that I mentioned in the whiteboard. So in this graph, it's actually something that the folks that I mentioned before on the paper created. Let's say that everything starts with this process that is first created. So first of all, in the header of the actual process and every subsequent one, you have information like, of course, the container ID, another metadata or runtime information like the host name, the distribution of the Linux version, the kernel version, SysFlow version itself. So all sort of details in that header. And the process starts with this object ID, and there's actually a CID for container ID that we may or may not see here later. But the thing is that if this process launches another process event, well, from here, from the object ID, we don't need to replicate all the information that is here because that pointer to the object ID contains all that. What we need to put in this process are things that are specific to this process, like the timestamp when it was actually launched, what type of operation it was, and that's the op flag integer that denotes what is it that this process is, the argument, you get the point with every one of these. They point to the originator, and of course this can get more complex as more things are actually launched. But notice also that as part of that, there's also network information. Okay, so for that process that we have the object ID pointing to has its own timestamp, the type of network event, all the source IP, destination IP, all protocol, all that information, amount of data being sent and received, all the richness of the net flows are here incorporated in the same component. And if this process actually launches another container, well, in the container ID, we get the information that points also to this original container ID, so no need to replicate that. So this is why we can address the issues that we went through in the whiteboard, and particularly the thing that I find very remarkable is that they copy. That's what I like to play with the word sys and net, and that's probably why they chose the name SysFlow, because they inherited the conciseness of the net flow from extracting the entire thing and extracting metadata about what was actually happening without having to store all the flows. And of course, it has an API. The logs are formatted in JSON, so no need for regex stuff. And of course, you saw that you have that container ID field. It's very light, and no longer you have the separation of system and networking. And I think that is beautiful. I'm really very excited about this. And in the last 3 videos of this series, at least from the beginning of the series, this may expand into other things, I'm going to be showing attacks into container systems and show that you can detect those with SysFlow and that you get networking information. I hope that I will be proving most of the point. I'm not going to be doing API calls, and I may or may not. I may show you the actual JSON format of the logs in QRadar on the subsequent videos. My apologies if this video ran a little too long.